Hello everyone, my name is Rick Costello and welcome to the universe we live in. Such a special place that we live in, and we're lucky to be here alive on our planet Earth. Now in this show I'm going to show you things that are up in the sky to see. Galaxies, globular clusters, and some star fields and all that, nebulas. And there's a lot to see up in our galaxy all the time. And soon I'm going to darken the sky here. And I'm going to show you what our sky looks like. There's no planets up in the sky. Actually, Uranus is up right now, but it sets shortly after the sun sets. And all the planets are up in the morning sky right now except for Jupiter, which is behind the Earth. So here I'm going to darken the sky, and what I'm going to do here, I'm going to show you how our night sky changes. We're looking here at the night sky in June, about 8 o'clock at night, and I'm going to move it to the winter sky or night sky and into the spring. And you'll notice a Milky Way band here. In our summer months, we're looking right in towards the center of the galaxy. And the center of the galaxy is right above the southern horizon. So here I'm going to shift the galaxy in a second here as I zoom in and show you the whole sky. And you'll notice how the center of the galaxy is right above the southern horizon. And then as we move into the winter months and then to where we are now in March, you're going to notice we're looking out of the galaxy now. Now our night sky is pointing away from the center of the galaxy, and we're looking out of the galaxy, which brings up a lot of stuff to see, especially galaxies this time of year. Now over here we have Orion's belt underneath my finger there. The 3 stars of Orion's belt in the constellation Orion. Now these are all massive stars, big stars. The one on the left, Aldebaran, is 6.4 million years old. It's a distance of 1,260 light years. It's about 33 times the mass of the sun. A huge star, about 20 times the diameter of our sun. Our sun's almost 1 million miles. This is 20 times bigger than that. Then we have the middle star, Aldebaran, 7.2 million years old. Distance of about 1,300 light years. And this has a radius of about 32 times the mass of the sun. And then Mintaka, the last star, distance of 1,200 light years. Again, a massive star, about 24 times the mass of the star, or the sun. Now here we're going to zoom in a little closer. You see the Orion Nebula down here. Again, we have the 3 stars of Orion's belt up here. And you have Aldebaran, right here. And we have the Horsehead Nebula here. Now here we're going to zoom in on the Orion Nebula, and there we go. The Orion Nebula is about 1,344 light years away. It's a giant cloud of gas and dust, mostly hydrogen and helium, but also heavy elements from stars that have blown themselves up in supernova. And then we have the Horsehead Nebula here. The Orion Nebula has got a mass of about 2,000 times the mass of the sun, enough to make hundreds of stars. And the Orion Nebula, it's about 700 stars that we can see right now, and some of those are actually forming planets around them, new solar systems. And then we get to then we get to the Horsehead Nebula here, and behind me you can see the little Horsehead here, just a dark cloud of gases and dust and no stars nearby to light it up, which is dark, and why it's dark. Now, the Horsehead Nebula is about 1,375 light years away from us. Each light year is about 6 trillion miles. And the Horsehead Nebula is a cloud of gases and dust, and it would be making stars in this cloud also. It's a beautiful thing, but you can't see the Horsehead Nebula with a telescope. You need long exposure photography to show that, but beautiful with that. I love the colors and all that. It's a beautiful gas cloud. And so now I'm going to show you some stars around Orion. We have the star up here, Betelgeuse, about 600 light years away. It's about a 10 million year old star. It's not going to live for very long. It's a very short-lived star. It's got a diameter of about 650 million miles, a mass of about 16.5 times that of the sun. It's a very massive star. It's going to be a very short-lived star, and we're expecting the next 100,000 years or so for it to blow itself up in a supernova. And you might remember a couple of years ago, astronomers were guessing it may be exploding because it was dimming. We thought maybe it was the beginning of the end of this star, but it turned not to be the case. It turned out there was actually a bunch of gases and dust between us and Betelgeuse that was blocking out the light from the star, but now that gas is starting to pass Betelgeuse and starting to brighten again. and it should continue to do that. But again, it's not going to blow itself up for a long time. It'd be nice if it blew itself up tomorrow. I would love to see a supernova, especially one this close. Close enough or far enough, it's not going to do anything to us here. But if a supernova went off, say within 100 light years away, that could be the shock wave could cause us a lot of trouble. But this one's far enough away, it's not going to cause any problem being 600 light years away. So now we're going to go over, there's Rigel over here, again a massive star, and it's about 863 light years away from the sun, mass about 21 times that of the sun. Again, it's a very hot star, massive star. It's going to live its life really quickly before it too blows itself up in a supernova. And if you notice the Rigel and then Betelgeuse up here, if you notice how bright they are, I mean, Betelgeuse around 600 light years away, and Betelgeuse almost 800 light years away, and they're still that bright. It's just Rigel is a massive star. So here we're going to go over Sirius now. Of course, Sirius, the brightest star in the sky. It's the ninth brightest star in our sky, and it's got a mass of about a little over 2 times that of the sun. And it's basically going to end its life like our sun will. It'll grow into a red giant, and then eventually its core is going to be turned to carbon and oxygen, fusing the helium into those. It'll end its life as a white dwarf. It'll lose the outer layers, and it'll just the white core dwarf star will be left. And around there is actually another star, white dwarf, another star like the sun, and it too had lost its outer layers. And then we're going to move the star Procyon over here, and below my hand there. And Procyon's about 11.5 light years away from us. It's the 24th closest star to the sun. And like Sirius, it too has a companion white dwarf star, Procyon b they call it. And it's got an age about 1.5 billion years, radius 1.5 times that of the sun. And the star right now is evolving. It's in about next 10 to 100 million years, it's going to swell up to a red giant and start fusing the helium into carbon and oxygen. And it'll swell up to 80 to 150 times its current size. A very big star. And above that, we have the stars Pollux and Castor up here in Gemini. And Pollux about 34 light years away from us, age about 724 million years. It's got a mass about 1.9 that of the sun, radius about 3 times the sun. A very luminous star. And then we have Pollux next to it, a giant orange star. And Pollux is right now fusing hydrogen into helium, and now the core is fusing helium into carbon. And again, it'll be like a sun-like star where it'll lose its outer layers and end up as a white dwarf. And then above that, we have the star Castor, 51 light years away. It's about 200 million years old, mass about 2.15 times that of the sun. And it appears to be just one star, but it's actually a quadruple system. It's actually, or more than that, 6 stars and 3 binary stars, pairs in that. But they're so close together, they look like one star. But again, these are massive stars, but not too massive. Then here we have Auriga over here. And Auriga's got the star Capella. Now, Capella's, it's got a mass about 2.5 times the sun, radius 12 times the mass, about 600 million years old. And it's about to start fusing helium into carbon and oxygen. It's going to swell up to a red giant when it does that. That's Capella in the sky in Auriga. So the next star we're going to look at is Aldebaran. Aldebaran's over here in Taurus, in the the Hyades star cluster. But now Aldebaran's about 65 light years away from us. And then the background stars in this cluster, those stars in this cluster are about 150 light years away from us. So the Aldebaran actually isn't in the Hyades star in a cluster. It's actually in front of us compared to that, but nonetheless, there's a Taurus, and again about 65 light years away, Aldebaran. It's about 1.16 times the mass of the sun, so a sun-like star. It's got a radius 44 times that of the sun, which equals about 38 million miles compared to our sun, which is 864,000 miles in diameter. It's about 6.4 billion years old. It's about 439 times brighter than the sun, a very bright star. And right now it's fusing helium in its core into carbon and oxygen. It's in the red giant stage right now. And being only a little more massive than the sun, it will end its life as the sun will when the helium helium core turns to carbon and oxygen. The fusion is going to stop, and with the red giant stage, and basically the star is going to be so big it's going to lose the outer layers to space, like our sun will, and the remaining core will be a white dwarf, basically a ball of carbon and oxygen, and that's what's going to happen at the end of the life of our sun, as well as Aldebaran. Okay, and one more thing we're going to look at in this area is another star cluster, the famous, right there, the Pleiades. We're going to zoom in on the Pleiades. Now, the Pleiades are about 444 light years away from us. It's an open cluster, a diameter of about 16 light years. Again, pretty big considering the closest star to us, about 4.2 light years. Now, it is among the nearest star cluster to the Earth. And there are about 1,000 stars in this cluster. Many are hot blue stars, very luminous stars, which are some of the stars that we can see with the unaided eye. But most stars in this cluster are less massive and dimmer stars, with many brown dwarf stars, which are not really stars. Brown dwarfs, their mass lies between the largest planets like Jupiter and the smallest stars, the smallest red dwarf stars. Brown dwarf stars, they'll be between the mass of 13 and 80 times the mass of Jupiter, which is less than 8% of the sun's mass. And they are not able to sustain nuclear fusion to become a star. If Jupiter had about 80 times more mass, it too would become a red star, a small dwarf star. And they all form about in the same nebula about 150 million years ago. Now the dust cloud that you see here, we thought that was part of the original cloud that these stars were formed in, but it turns out that these stars are just passing through this cloud. And so this is actually a cloud within the galaxy that the stars are passing through. But very cool stars to see. Again, about 1,000 stars in this young cluster. So now I'm going to show you some deep space stuff, objects in the sky. So we'll start around the constellation Orion, this part of the sky. And there's a lot of deep space objects. See nebulas, some globular clusters in here, a couple of galaxies. There's a lot to see. Now, back in the 1700s, Thomas Messier, he was looking for comets. And so he made a list of 112 different things that weren't comets, so they wouldn't be mistaken for comets, and they turned out to be the Messier objects. And the first one we have here, we're going to zoom into the Crab Nebula. And the Crab Nebula is about 11 light years in diameter. It's about 6,500 light years away from us. And back in the year 1054, the Chinese, they logged this, they saw this in the daytime. It was so bright, this Crab Nebula, the supernova that went off. And it takes 6,500 light years for the light to travel for the Earth. That means the actual supernova happened about 7,500 years ago, and by the time it reached the Earth, it was the year 1054. And at the center of this expanding gas, there's a remaining core, which is a pulsar, which is a neutron star. And a neutron star, when the core collapses, the cores are, they begin as the cores, atoms are, protons, neutrons, and electrons. And what happens is the gravity is so strong it crushes the neutrons into the protons, turning the protons into neutrons. And what you end up with is a ball of neutrons. It's a very, very heavy matter. This is so packed tight together. Roughly a neutron star anywhere from 1.3 to 2.5 solar masses can be in this neutron star, maybe 11 or 12 miles across in diameter. And the matter is so packed, so tight that just a sugar cube size would weigh about 1 billion tons, as much as Mount Everest. And this cloud has been expanding at about 930 miles per second. And it contains all the elements to make everything in the future, everything from hydrogen, helium, which was there at the beginning of the universe, and other elements, heavier elements that were forged in this star, creating all of the elements up to uranium with 92 protons. And so this is where all the stuff that made us, all the atoms in our body, it came from these stars that fused hydrogen into all the heavier elements before blowing itself up and throwing those elements out in space. And later on, they can form new stars, and now the elements for planets and us too. And that's the Crab Nebula there. Okay, now I'm gonna move over here, and we'll show you more of the sky here. We're gonna look at the Andromeda galaxy over here. You see M31, and Andromeda is about 2.5 million light years away from us. And here we're gonna rotate the sky a little bit, and we'll center Andromeda. And now Andromeda is in the northwest part of the sky right now. It'll be up for another month or so before it sets, but really easy to find. If you go up here, you see the W of Cassiopeia right there. But if you go to the bottom part of the W, you notice it's more of a perfect triangle. But if you go where that's pointing, maybe about 5 inches at arm's length, it'll run right into the Andromeda galaxy, which is right there. And about 5 inches at arm length. Or you can go to Pegasus. If you go up to the corner star here, Alpha-Res, the northeast corner, Alpha is about 100 light years away from us. But besides that, and then if you bounce north here to this star here, Marok, about 199 light years away. And if you go to Mark and then go over here, next you'll find Andromeda. It's really easy to find either two of those ways. Now Andromeda is a massive galaxy. It's a larger than our galaxy. It's about 200,000 light years in diameter, probably a little bit bigger than that. But it has over a trillion stars in it. And right now it's moving towards us at about 68 miles every second. And 4 or 5 billion years from now, it will also collide with our galaxy. And again, it has over 1 trillion stars, the largest member of our local group of galaxies, about 52 or so galaxies in our local group. And it's got a diameter of 220,000 light years. And Andromeda is actually, in the Berkshires, it's the farthest thing we can see with our eyes. You can see the center of Andromeda. The center here is about the size of the full moon. And if you have a fairly dark sky, you can actually see that. It's about the size of the full moon. The whole Andromeda, if we could see the spiral arms and everything, it'd be about 4 full moons side by side. So it's pretty big in our sky, although very dim. It's hard to see the spiral arms from here, even with a telescope. They're very dim, just kind of making them out. But the center is really bright and lit up. Very cool galaxy to see. Another galaxy near Andromeda, M33, Messier object number 33. And it's like Andromeda, we can see with our eyes. They say the triangle galaxy, which is M33, is the farthest galaxy we can see with our eyes. But I don't think it's bright enough. I don't think it's dark enough, the skies in the Berkshires, to see it with our eyes. It's probably like you need really dark skies, like Arizona dark, to see it. Now, Triangulum is the 3rd largest galaxy in our local cluster after Andromeda in our galaxy. And it's a little bit further away than Andromeda, at 2.7 million light years compared to Andromeda, which is 2.5 light years. But it's only about 750,000 light years away from Andromeda. And like Andromeda, it also is moving towards our galaxy. And about 1 billion years after the Andromeda galaxy collides with us, in 4 to 5 billion years from now, about 1 billion years later, M33 is going to collide with our galaxy and make it a little bit larger galaxy when it combines with the 3. And the size of it's about 60,000 light years in diameter, M33 is, which is smaller than our galaxy, which is about 170 light years right now. But a beautiful galaxy to see through a telescope or some long exposure photography if you do that. But a beautiful galaxy. Next thing we're going to look at is the M79, a globular cluster. Now, these globular clusters, most of them can be seen in the summertime. It's kind of odd to see one in the fall or this time of year in the wintertime. Most of the globular clusters are over the center of the galaxy. And so let's zoom in on here. I think I'll step out of the way here. There we go. This galaxy is about 42,000 light years away in the constellation Lupus. And there are about 149 globular clusters, but most of them can be found above and around the center of our galaxy, above the But this one, this globular cluster actually may be a captured one, maybe from another galaxy that joined ours. And in these stars, in these globular clusters, very old stars, 10 to 12 billion years old, these stars. There's no massive stars anymore. Any massive stars that have formed, they lived their lives quickly, and they blew themselves up in supernova billions of years ago. So these are all like sun type stars or smaller stars, a little bit bigger than the sun, that'll last billions of years. And the remaining of these stars are, like I said, they're low mass stars, a lot of these stars, and they'll live for a long time. Now, if you live on a planet around any of these stars, if there's any life on these planets in these globular clusters, your night sky would just be filled with stars. These stars are fairly close together, maybe a few light years apart at the best. And then it gets even more compact as the closer the center you get to these galaxies. There's a lot of stars in these galaxies. Again, about 12 billion years old, these stars. Very, very cool when you think about that. Now we're going to shift away from the Orion area. We're going to move to the northeast part of the sky, and we'll look at my favorite galaxy cluster, the Virgo galaxy cluster. And it's between Leo and the Virgo. And so there's Leo right there. And now just to the left of Leo is this cluster. And here I'm gonna move the clock up to about 10 o'clock at night. It's about 8 o'clock right now, but we'll move it up to about 10 o'clock to bring it higher in the sky. So there it goes, shifting up higher in the sky there. And we'll stop again, as I said, about 11 o'clock. There we go. And again, we have Leo there. Now, this whole area is just full of galaxies. As we start to zoom in here, you see these blotches here. And I was going to move it over a little bit, and then we'll back off a little bit. And you see all these splotches that you see. Those are all galaxies in there, the dim stars. Now we're going to zoom in on a couple of galaxies out there. I think I'll switch to this side. It's probably a better angle over here. Now here we have the Markarian chain, all these galaxies here. And here we zoom out a little bit, and there they are. And these are all, these galaxies are about 50 to 60 million light years away from us. And we're seeing them as they looked 50 or 60 million years ago. It's taken that long to reach us. Now, as we can see, we have a good mix of different types of galaxies in this cluster. There are a few spiral galaxies, there's some elliptical galaxies, irregular galaxies, and the whole area of the sky is just filled with galaxies. The Virgo galaxy supercluster, they call it. So the chain of galaxies. We may be part of this chain at the outer edges of this string of galaxies. And our local group of galaxies include the Andromeda and M33, which are part of this, could be part of this long chain of thousands of galaxies. This part we're going to show you things around the Big Dipper. We have the Big Dipper here, Ursa Major, the bear they called it. Doesn't really look like a bear to me or probably anybody else these days. But yeah, so a couple things to look at. Over here we have Polaris, the North Star right there. And one way to find Polaris, if you're lost in the woods, is look for the Big Dipper. And if you go to the top two stars here on the front of the pot of the Big Dipper, if you take those two stars and follow a direct line, straight line, it'll take you right to Polaris, the North Star. Now Polaris is part of the Little Dipper, Ursa Minor, and and the Little Dipper is always pouring into the Big Dipper, so it's always above the pot of the Big Dipper. And so here we're going to move around to a galaxy, the whirlpool galaxy, M51. It's located just off the last star of the handle of the Big Dipper. And here we're going to zoom in onto it, and here it comes. A beautiful galaxy to see through a telescope. There we go. Now, the whirlpool galaxy is about 28 million light years away from us. It's got a diameter of about 76,000 light years, about 43% of the size of the Milky Way galaxy. And behind it, you see the second galaxy, NGC 5195. It's a companion of M51, and it has twice passed through the whirlpool galaxy. 600 million years ago, it passed through. And then again, 50 to 100 million years ago, it passed through. And as it went through, and then it actually started a lot of star forming going on in this galaxy. There's a lot of stars, new stars being formed. And over time, this galaxy, this smaller galaxy, will join in the whirlpool galaxy, and they'll form a larger galaxy. But again, a beautiful galaxy to see through a telescope or long exposure photography. So the whirlpool galaxy, M51. Okay, so that's the end of the show. I hope you enjoyed seeing some things that are up in the sky. A lot more stuff to see up in our galaxy. But a couple other things I do is hobbies of mine. I do telescope shows. If you ever want to join me sometime, the picture of my telescope, and I do programs for the public all over the Berkshires. You can find me on Facebook if you want to contact me and see. And I post when I'm doing shows around the Berkshires. Or if you want to hire me for private parties or groups, that's fine too. I do those and lots of those. And a second thing I do here are astronomy paintings. And these are some of my paintings on the wall here at a showing I was doing. And they're all astronomically correct paintings where every star is right where it belongs. Every star goes on the canvas one at a time. And I try to make these correct scenes of our galaxy and our place within the galaxy. So some of the things that I do. So thanks for joining us tonight on this show. And I appreciate you watching the universe we live in. Very much appreciate it. Again, my name is Rick Costello, and Mike Snoppley helped me produce this. And we both thank you for watching.